Good afternoon, ladies and gentlemen. Welcome back to the administration track here at Summit 2018. Good to see you all still alive after drinks and last night with the partners. Coming up next, we've got one of the most anticipated talks, I think, here at Summit on Jira performance testing and what we've been working on. So please welcome up to the stage Maciej to talk about it.
Hi, my name is Maciej Kwieciński. I'm a software developer in Jira Server, and I've been working on performance for the past 4 years. And today we'll talk about Jira performance testing in Jira Server and Data Center. And I hope that after this presentation, you'll be better equipped to help your users stay focused and productive. So we'll start off by reiterating why performance is important and how it affects your users. Then I'll tell you how performance testing evolved within Jira Server. I'll highlight the biggest challenges we faced and how we solved them. I'll continue by showing how we currently use our toolset and how you already benefited from it. And we will wrap up by showing our plans on releasing our internal tools so you can reuse our experience and solutions with our toolset. So let's imagine you're a Jira user. Your team needs to build something awesome and you want to help out. So you open up Jira and you want to gather some context, maybe update your progress or see what's left to do. And you follow a link or click a bookmark or navigate within Jira itself, and you expect to see something useful. But sometimes, instead of seeing something useful, you see a white page or a throwbar, and you just have to wait. This is a table from high-performance browser networking by Ilya Grigorik, a performance engineer from Google. It shows how a visual delay affects user perception. So if a delay is under 100 milliseconds, it feels instant, and users won't even be able to see it. If it's over 100, they will be able to perceive it, but they won't really notice it. But when you go over 300 milliseconds, they will start noticing that the computer is working or thinking about something. If you go over a second, they will most likely start thinking about something else than the task they attempted. And finally, if you go over 10 seconds, they will often start refreshing the tab, trying another approach, or give up on the task completely. And in Atlassian, we understand how important it is to keep users out of the yellow and the red zones. So we invested in performance improvements and toolset to make it possible. In fact, we've been working on performance for years. For example, my team is entirely devoted to building performance tools in order to empower the other development teams in their performance initiatives. And testing is our main way of ensuring performance gets better. And in this chapter, I'll show the challenges we faced, how we solved them, and how they shaped the tooling around, how they shaped the tooling we use nowadays. So the known history of organized performance testing in Jira starts with data scaling reports. Back in 2014, we released Jira 6.4, which was focused on enterprise performance. It was accompanied by a public report to highlight the value brought by the release. And you might have seen the report. You can find it by Googling scaling Jira 6.4. It goes into detail on how different data scales and affect user performance across different Jira versions. And in order to be transparent, we started to publish this report for every minor release since Jira 7.3, even if a release didn't ship awesome improvements to show off. We publish these reports so we can make informed decisions about Jira upgrades and data. So let's see how it looked back in 2014. We already had a lot of tools to help us out. We had a few data sets of different shapes and sizes. We got a bunch of scripts for starting up Jira, and we had a load generator using browsers to send standard traffic to Jira, and we had a service to visualize and track the results. So we've got a lot of the hard stuff already done for us by the tools. All we had to do is to pick a data set, pick a Jira version, launch a few scripts, wait for them to finish, repeat the entire thing 20 times for all 20 combinations of data sets and versions, compare them, contrast them, interpret them, and finally formalize them into a report. And this is still a long list of manual tasks. And manual tasks display a common set of problems. First of all, how do you even start performance testing? Each of the tools has some guides and documentation, but it's often not obvious how they fit together. So yeah, they're often the previous person that did the performance test wrote some wiki pages, but they often go out of date and no longer work. So usually in an organization, there's only a few people that know how to run performance tests. And that's a common and notorious problem known as tribal knowledge. So let's say you learned how to run the perf test the hard way, and you paid the entry cost, and now what? So you probably need to prepare the infrastructure for testing, restore a Jira backup, and generate traffic. And each of these operations takes time, and you need to monitor them in case they fail, and you definitely need to wait for one to finish before you start the next one. So they require constant oversight, which costs time, energy, and focus. So let's say you did all of that, and now, for example, it turns out you used the wrong backup, and you need to do it all over again. So with manual steps, every mistake is very costly to fix. It multiplies the overall cost of performance testing. So if you had any of these kinds of problems, you might also know that they reinforce each other. For example, when we use JMeter scripts to compare two versions of Jira, and we saw that one of them has faster response times, so we concluded this is the better version, this is the faster version. But later on, after we dug in, it turned out that one of the Jira versions was throwing a lot of errors. And error pages render very quickly. They have very good response times. So JMeter was reporting them as fast response times. And we caught that. We had to invalidate all of our test results from this run and all the previous runs that we made. And we had to keep this fact in mind to do it manually every time for all of the future tests. And that's how tribal knowledge, knowledge how JMeter works, can lead to error proneness. So let's see how we in Atlassian attacked this problem. So we addressed that tribal knowledge problem with end-to-end tests. For example, we built a test which lets you pass two Jira versions, and you run one console command, and you simply await the list of things that went wrong. Or if the list is empty, you're all good. Its source code is basically the alternative of all the guides on the wiki pages and so on, but it has the advantage of not going out of date because you can just run it and see if it works. And remember the wrong conclusion from the JMeter fast errors. We fixed that in our end-to-end tests by only counting the successful response times. And we also added error checks to warn users, hey, there are errors. We should look at this, and probably the test has failed. And this one fix, we just incorporated into the end-to-end test, so every user that uses it doesn't even need to worry about it and doesn't even need to know about it. It just works. It's a feature of our test. And thanks to the fact that only one command runs an entire test, we were able to constantly run a lot of those tests. So we quickly found places where things randomly break. So we introduced retries of certain operations. We added timeouts and error reporting so we can find them. And this process made things like dataset restoration like Jira installation or SSH connectivity, robust and reliable. It's like didn't flake anymore. Since there's so few steps, there are only a few occasions to make a mistake. So, and even if you do make a mistake on a manual step, it's really cheap to rerun because it's just one console command. Moreover, we built these tests upon a strict programming environment. So a lot of the checks are done automatically out of the box by the compiler, even if you customize the test. And it tells you what's wrong in a matter of seconds rather than after the test, after hours of trying. And the tests are reused by many dev teams internally. So if any single user of these tests finds an error, we fix it once, and everyone benefits from this knowledge. I lost the slide. Let me try this. All right, we're back. Okay, so we used automation, tight coupling, and the best software development practices to significantly cut down the cost of performance testing. However, the low cost is not the only factor in an investment. We also needed to make sure that the value provided is as high as possible. So the main value of testing is measuring things that matter, which in this case is the user experience. Back when I was in a performance team for Jira Cloud, we found that the majority of latency on production is spent on the front end, so in the browser and not in the server. And since then, I moved to Jira Server, but backend, it's still not enough to explain the entire latency. On our internal instances, it contributes a mere 10 to 50% of the total latency. So it would, if we would only measure the backend, we would be blind to serious performance regressions in the user experience, and we would be close to awesome improvement opportunities. For an extreme example, Gmail has an offline mode and doesn't talk to the server at all. So does it mean that Gmail doesn't have any performance? Can the performance be better or worse? No. The users talk to the browser and not to the server. To reflect that, we launch multiple virtual users, which mimic real Jira user behavior. And they interact with the web pages via real browsers by clicking, typing on a keyboard, and waiting for visual elements to appear. And this way, we are more confident that our tests are measuring things that really impact the end users. Using this approach, we've been able to detect both back-end and front-end regressions. And even though the users don't talk to the server directly, the browsers do so on their behalf. So we do apply some load to the server. And each browser, on average, produces 3 HTTP requests per second. And some of our tests reach over 500,000 HTTP requests an hour. So that was how our tools were evolved and designed. We called them Jira Performance Tests, or JPT for short. And let's see how we use them nowadays, and let's see how you already benefited from it. So we run many kinds of tests for different purposes. Data scaling reports let you decide how to grow your data and how your instance might be impacted by an upgrade. The regression tests check every single development change to make sure you won't get a nasty surprise after upgrading. And ad hoc experiments let us explore ways to proactively improve performance and make Jira faster. So currently, the data scaling reports cover both Jira Server and Jira Data Center. And they compare 2 versions on 10 different data sets. So that's 40 combinations, so 40 tests to run. But still, it only takes a single console command to run them all, and they take around 80 minutes in total. The ease of use and the low maintenance cost allowed us to delegate these reports to the release team, so they are no longer blocked by inter-team scheduling conflicts and priorities. And we were able to fulfill our transparency promise and release this report every minor release, despite our increased frequency of these releases. And for us, it's a proof that the tribal knowledge problem has been addressed effectively. We automatically check the performance impact of every change introduced to Jira Server and data center on a big data set. It's run very often because even the most innocent change can have a very serious impact on Jira performance. They were included in our automated build process around autumn 2017, and they caught multiple regressions since then. One of the thousands of changes we tested was intended to be a performance fix, so that's kind of ironic. It accidentally uncovered some ancient bugs with index logs that never was touched before, and it caused the performance of agile boards to slow down to a crawl. So the automatic test caught that, and we were able to fix the ancient bug and unblock the performance win. And another time, we found that a new feature incorporated into the quick search caused the Jira frontend to send a request on every key press, and that obviously very quickly degraded performance. And it's not something we would find with a simple HTTP load generation tool or a load replay tool. So we are very glad we are using actual browsers. Right, so regression tests covered the risk of unexpected negative performance changes. However, at Atlassian, we know it is not enough to stand still, and we need to move forward to accommodate for your growth. So we gave the dev teams a way to build their own hypothesis tests, and hypothesis tests basically answer the what if question. We use them to test a few speed-up ideas, and confirming or disproving our assumptions about performance has let us focus on the improvements that actually make a difference. And performance is very tricky. Sometimes a performance fix is looks good on paper, but in reality, it's actually under regression. So hypothesis tests helped us ship high confidence fixes like custom field optimizer, per project permission jQuery queries, and data center project replication consistency. But even our biggest Jira instances are tiny compared to the largest customers. And we asked ourselves the question, what if we grew as fast as our biggest customers do? And analytics show that some of our largest customers grow their issue count 23% year over year. And in order to simulate that, we built a Jira app which inflates the current issue count up to a given number, while still preserving the distribution of issue counts over projects, links, boards, etc. But data growth is not enough to meaningfully represent the higher scales. Back in May, our internal Jira grew over 30% year over year in terms of monthly active users. In order to simulate such high amounts of traffic, we adapted JPT to coordinate multiple virtual users from multiple physical machines and gather and merge the results into one place. So when we had all the tools necessary to explore the biggest scales and beyond, we were ready to perform a growth experiment. The plan was to grow and stress our instance until it breaks, and then try to repair it. So we used our pre-production environment to mimic the same setup as on our production. We had the same hardware, apps, config, and data. And the initial production data was the starting point, which we took it and simulated a year of growth by inflating the issue count with our issue inflation tool. Then we took the access logs from production and parsed them to find a representative initial virtual user configuration. And we simulated the growth of traffic simply by increasing the number of virtual users. We ran a stress test and observed the results. And if the performance was okay-ish, we'd go back to growing, and we'd keep on growing and stressing until the performance was terrible. So when we finally reached the poor performance threshold, we explored different ways of restoring performance at this scale when it broke. So let's jump straight into a result of our first stress test. This is a chart generated by JPT. And we use this kind of chart to observe performance of our internal Jira instance throughout the growth experiment. The x-axis represents the elapsed time, and the test took 1 hour. The blue line is the overall latency experienced by the virtual users, and here it starts off high at like 8 seconds, but that's due to cold caches. Then it quickly stabilizes between 1 and 2 seconds. The green line is the overall throughput achieved by the virtual users, and it starts off low, again due to cold caches, and then stabilizes at around 300 actions per minute. And the green line, the red line is the error rate. So basically, it's the percentage of actions that failed, and we consider an action to fail if the user doesn't see what he expects to see, or the page times out, or it's an error page, anything that stopped the user from getting the value out of Jira. Here it's 0%, so basically no errors. So this is the year 0 of the experience, which represents our current scale. This is 1 million issues and 10,000 monthly active users. And the performance is all right. There are no errors, and the latency is under 2 seconds consistently. So we grew our Jira and tested it year by year by year. And 4 years into the simulation, we are at 2 million issues and around 23,000 users. And we can see the performance is still doing OK. There are no errors still. The latency is higher, above 2 seconds, but not much higher. It's still stable. And the throughput is more or less stable and higher at around 450 actions per minute. And we have higher throughput now. And it makes sense because we have more users and therefore more load, more traffic. 7 years into the simulation, we are at 4 million issues and around 68,000 users, and the performance looks really bad. The errors start popping up, and they oscillate at around 5%. That means an action fails once every 20 interactions, which already is probably totally unacceptable for most users. The latencies are very unstable. They oscillate at around 9 seconds, and the peaks reach like 3 minutes. And the throughput is worse than 3 years before, even though we have more users. So that's poor performance right here. But we kept on going. Year 8, 5 million issues, 90,000 users, and performance is catastrophic. Errors spike to 40, 70, and even 100%. And they nicely line up with the latency bumps, which suggests that most of the errors are timeouts at this point. And latency is regularly over 20 seconds. Yep. So, and the throughput falls really low. It goes down even to like 30 actions per minute, which is like 10 times less than on year 0, which is and we concluded that at this point, we reached our criteria for catastrophic performance, and we concluded year 8 is our absolute limit of scale of our current instance. And it's actually amazing to see how fast it broke. Over the first 7 years, it started degrading very gradually, and finally, boom, it's like almost unusable out of the blue. So we learned that our current setup will probably hold for around 4 to 5 years. But what now? We dug into the various low-level system metrics and logs and found that garbage collection is a real performance problem at this scale. So we explored 3 independent solutions. Since we saw problems with GC, we tried tuning GC, and we switched from serial mark sweep to concurrent mark sweep. And it was an improvement. the errors no longer spike to 100%, and the latency is no longer spike. Sorry, the latency is no longer spiked to 3 minutes as before. But it's still pretty horrible. Latencies consistently go around 20 to 30 seconds. And the errors are often over 10%. So we still see this regular pattern of like choking, getting better, which hints that the instance is unstable, and over a course of a longer test, it will probably die as well. So it's only a slight improvement. But this reconfiguration costed me to nothing. So our instance is a Jira data center cluster with 2 nodes. So for the second fix, we decided to see if adding more nodes will help us scale. So we added 2 more nodes, 4 in total. And we ran the year 8 scale test again. And it helped a lot. The errors are mostly 0. And even the most pessimistic latencies reach like 9 seconds, which is still suboptimal, but a lot better than 3-minute spikes or 20 to 30 second latencies. And the throughput is actually higher than before, at around 600 to 700 actions per minute. So the performance is restored to an operational level, while increasing the hardware cost 2 times, because we have 2 times the nodes. So for the third fix, we used stronger hardware. We increased the number of cores from 8 to 36, memory from 15 to 60 gigs, and the JVM heap from 6 to 12 gigs. And this looks much better. The errors no longer happen at all. The latency is between like 2 and 3 seconds, which is very comparable to even year 0. And the throughput reaches even 1100, which is the highest throughput we achieved yet. So this result is the most promising of all for us, for our setup, and it increased hardware cost about 4 times in our case. We are very confident that the solutions we explored will help us in the future, because the test used the data seeded with our production data. The traffic was based on our production access logs, and it was run on the pre-production environment, which is identical to our production environment. So the same hardware, the same config, same apps, and then everything. Now we can plan the investment in hardware or nodes ahead of time and choose the most cost-efficient solution for us. We interviewed numerous Jira admins, and we learned how different each Jira is. And we will try to reflect those different flavors and shapes of Jiras in our internal tests, but nothing will approximate your unique setup better than your own unique setup. That's why we want to support you in testing your instances. We plan to release JPT to the public, so you'll be able to benefit from the experience and solutions we developed to combat the challenges of performance testing. We want to help you test hypotheses like, when will we need a hardware upgrade, or how would archiving these projects help? It will ship with the virtual users using real browsers, and they know how to explore Jira, so they visit different pages, they try different JQLs, and they remember everything they see along, so they know where the issues are, where the projects are there, so where they can create issues, and so on. And they will naturally respect the permissions that are set for the users. They will only see what you allow them to see. And they will work with your data out of the box, because they just explore the data like a web crawler, basically. And all of it will work even behind the firewall, so you don't need to expose your instance to the internet. We also plan to release JPT to app vendors. We believe it will help them gauge the performance impact of their app on Jira. And it will allow them to provide a better product for you. We plan to address their biggest pain points, like infrastructure provisioning, enterprise-scale data sets, and a reference traffic profile. And the main use case we want to support is the impact test. So how does Jira work with and without my app? We'll start with a closed beta release, followed by an open beta. And in the early days, we expect that JPT will probably won't work in all occasions, and there will be some unforeseen circumstances where it will break. But that's what the beta is for. So try it out and let us know how we can improve it. And we are hoping that your feedback will let us improve our own internal tests, so we will be able to ship more value with more confidence to all of our customers. If you're interested in trying out JPT, use this link to watch the release ticket, so you'll be notified when it's ready for you. And if you don't, we'll still send out additional announcements when there's more to share, so keep your ears open. And that's it for Jira performance testing.
All right, thank you very much. Are there any questions? Oh, lots of hands. Okay, hold on. Let's start at the front.
Hi, that was great. Thank you. Only half my traffic is from users. The other half is from scripts. Is there a way to model that?
Yeah, so currently we don't support non-user traffic, but we'll definitely open to that. Our tool is very flexible. A lot of things are possible, and it's just a matter of development, basically, simple matter of programming.
Any chance of seeing this for Confluence, Bitbucket as well?
So right now we support Jira Server and Data Center only. We are exploring ways to make tooling consistent across products, but that's in the very early stages of basically we are at the research phase right now.
Anyone else?
How did you determine what your growth rate was? So you went from year 0 to year 1, year 2, year 8 was 68,000 users. How did you figure out that's what you were going to get to in year 8?
So do you mean like how did we choose the number of users? Right. So we monitor our instance, and we have a estimate of our monthly active users, and we also have our Access production logs. So we combined. So we knew our Access logs represent this amount of users, and we also have historical data about how our monthly active users numbers grow from year over year. So we took this figure and we just simulated what if it kept happening every year. And we basically multiplied the number. Yes, we needed historical data.
Any chances of sharing the standard errors when you encounter the issue? Because we may not face the issue at the same time, maybe later down to the 3 years, 2 years to our systems. So any chances place we can share that, and our monitoring systems will look into that errors and fix these issues as you have done.
Sorry, I couldn't. Could you repeat?
Great. So you run a lot of test runnings, test cases, and your monitoring system will analyze so many logs, and it will generate the errors, and you will fix it, right, in your systems in Jira when you are for the cloud or any instance. So if you got those kind of errors to in our system, there any place we can get download, and our monitoring system will look the same type of error, so that we can also fix similar kind of issues.
So I think what you're saying is you would like us to share the errors that we found through these performance tests, so that you can, okay.
All right, yeah. So yeah, basically all of these gotcha moments are, that's how we were doing this testing wrong. We initially started writing them up on pages and so on, start sharing them and so on, but they often got lost, and they quickly went out of date. So we basically embedded this knowledge into the tool itself. So basically, if you use this tool, you'll benefit from this kind of error, and maybe our source code is probably not as readable as natural English language, but yeah, we want to have one source of truth, and basically, if you want to see all the things that we caught and so on, maybe a list of like the issues we fixed. Maybe we have like a lot of issues in our backlog, and each of them is a small, bigger, or less or more important gotcha moment, right? So maybe our history of development of this tool would help us. Yeah, actually, that's a good point. Yeah, so testing is one thing, but monitoring is the other thing. They can have similar classes of problems. Yeah, that's a good point. Yeah, we probably should have included in the documentation. We are like actively documenting the tool from the code level and from the like user journey level. Yeah, so I'll definitely find a place to put these gotcha moments in the documentation. Yeah, that's a good call.
We'll take a note. We'll make sure it gets in there.
Yeah.
Do you handle different degrees of latency?
What do you mean by a degree of latency?
Network latency. Between
Yeah. So we don't drill down yet. Now we only have like the end user perspective. Like they don't know if it's the network or the server or the like JavaScript execution and rendering and stuff. But we are planning to give a drill down to see where the problem lies.
We want to see the difference between, like a 200 millisecond latency between a remote site and the server, and 50 millisecond, right?
Okay.
The remote users say that Jira behaves differently in different sites.
Yeah. All right. So right now, that depends basically on the testing infrastructure. So if your setup is already geographically spread, then you can like test it with a hypothesis test. But if you mean like a test that in the cases where we provision the infrastructure in AWS, we provision it all in a single region. So basically, there's basically local host latency at the moment, but we are open to accepting like a geo-spread setups in AWS as well.
Yeah, is it possible we can run the test on different functionalities parallel, like the core Jira functionalities along with the service task, add-on plugins, like in parallel, like some ratio, like 20% test cases running on a core Jira, like 10% service desk, and rest 70% running on an add-on plugin like timesheet, like structure, like etc. And also, is there also a way we can actually collect the system metrics like I/O utilization, CPU, memory, garbage collection, or MySQL, anything like, and then we have any consolidated report like this is the test result for all the test cases, and this is the system metrics.
All right. So starting with the different kinds of traffic, like for service desk and plugins and so on, our traffic model is composable. So we have like a core coverage, and you can add to it like an app-specific or product-specific knowledge as well. Actually, internally, Service Desk also uses this tool, and a Portfolio also uses this tool internally. So we have some first use cases where we do compose traffic from multiple sources of multiple types, and this will we also want to support this for the app vendors out there, not only internal. And about the system metrics, we do include some basic system metrics like CPU, utilization, some GC stats, and so on. We do provide in some reports. Like this chart that you saw, actually underneath, if you'd had the full version interactively, underneath there's a lot more charts with system metrics. And we don't have like one huge consolidated report with all the details. We have different reports on different levels of abstraction. So maybe this chart shows you how the test looked over time, but we also have like entire summaries and aggregates. This is the average latency for all actions and so on. We use those in the data scaling reports actually. So we have like we aggregate the entire performance into one number at some point, and we expose this as a report with also some drill down. And one other way of reporting is the binary judgment call. Is it this good or bad performance? And we also include it automatically, so you can express your non-functional requirements. You can say, I expect the issue page to be at least, at most, 1% slower than before, or something like this, and we'll automatically check this and fail the test if it's surpassed.
Hey, you mentioned that you did some changes in CPU and RAM and heap size and everything. Did you also look at different, like RDS versus a manually configured database, the different database backends, EFS with different throughput profiles versus a custom NFS server?
Yeah, so in this experiment, it was more like a validation for our tool. Will it show the problems of higher scales? Is it able to overload our Jira and so on? And we wanted to show if different approaches will actually translate to different results. And we saw that, and we didn't explore all the full possibilities of how to fix it in the future. And there are so many combinations you could test. So we wanted to focus on some of them at a time. We didn't test RDS yet.
All right, that's all the questions we've got time for, I'm afraid. We will be around after the talk. If you want to see us outside, you can ask some more questions. Thank you very much for coming.
Thank you.